Here we go. We're actually doing this. We're actually doing this. I can't believe I'm actually doing this. Well, 5 days left and hi, how's it going? Hey, how's it going, chat? I'm first. I saw Shadow Wolf do it first. You're back, cool kid. He was here during my like test stream yesterday. While I was oh fuck. I did not mean to have this going. Alright, and then I copy paste this here, here, and what is the timer for? Funnies. It's for the funnies. Alright. But for real though, we are doing a stream. Alright. This speedrun timer is going to be used to keep track of how long that I've been doing this. So obviously I gotta learn how to code inside of Hey, should I reset the timer? You cannot reset the timer. No! It's not even... It hasn't even been, like, the thing hasn't even started yet. Alright, this should... Oh my god. You're asking a lot from me. Spam call Eric. I think he'd get mad at me. I think he'd get mad at me if I spam called Eric. Bro, do it. Eric. Eric. Get in my stream. Because I'm speedrunning making a game.
Okay. I gotta go to bed though.
There, I did the thing.
What thing?
Nothing.
The ooh?
I'm not doing the ooh. Alright. Alright, we have this timer. It's gonna be up
Wait, one
here.
last time for old times.
You motherfricker!
I'm doing.
Cool kid! No! Ew!
Man of tape. Thank you.
No, you didn't. Good boy! Shut up! Shut up! Ew! Freaking, why? Cool kid, how many stuff? I'm not doing it again. I'm not doing it again.
Why is he an admin?
Who's my little good boy? You are. I'm not doing it again. Screw you. Anyways, nah, he's mine. Okay, stop. I'm taking it away from everyone. I'm taking it away from everyone. Bro, do it. I'm taking away the oohs from everyone, including Eric.
Hey, you can't take it from me. I'll get it from you somehow. I won't like it.
You're not gonna do. You're not gonna take it from. You're not just gonna. You're not
My
just
booty
gonna.
is bomb. You cannot have it. My booty is bomb. You cannot have it.
Guys,
Oh, fuck it. Okay. Well, I'm gonna get it one way or another.
you're gay / true. I am not gay.
Do me a favor. Hey, do me a favor. Take away his admin.
Oh, okay. Hold up, should I go live on YouTube as well?
No.
Alright. For real though. Why is it so laggy? I'm sorry, but what?
Take away Cool Kid's admin.
I did! Anyways, we're gonna start the timer. Bro, I spent $12.50 for nothing. L. Anyways, we're gonna learn how to program chat. Or I'm gonna learn how to program. 3, 2, 1.
GD script, a
Oh,
high-level, object-oriented, imperative, and gradually typed
How do I freaking
programming language with syntax a lot like.
hold up. I need to start. Motherfricker is not letting me start.
You know what's funny? Like, genuinely, I didn't know you could change the audio tracks. And now I know you can change the audio tracks. So the guy, this guy who was explaining rocks, and he said, I'll tell you more about these rocks.
Script, a high-level, object-oriented, imperative, and gradually typed programming language with syntax a lot like Python built specifically for good Go. I know that sounds like a lot, but today we're going to learn it. While it's of course impossible to cover everything an entire programming language has to offer in just one video, we'll certainly try. In fact, we'll cover everything from variables and conditionals to getting input, inheritance, dictionaries, signals, and the list goes on. And who knows, perhaps we'll even figure out what GD stands for.
I lost my streak.
Green Day script? Gadolinium? We might never know. We'll start with the things that are considered to be most important for beginners, and then move on to more abstract programming concepts as we progress. It's not as much a follow along as it is an overview. So, if you're a beginner, lean back and know that you don't have to understand everything the first time. Also, it's totally okay to stop the video and try some of these things out. You can always come back to it at a later time. We've made sure to split everything into clearly named sections, so hopefully you'll be able to use this as a reference manual going forward. And if you're a seasoned programmer transitioning to GDScript, this video should provide you with a nice overview of the tools at your disposal and how to approach doing different things. Keep in mind that this is a video on GDScript, not an introduction to Godot. So if you've never opened up Godot before, I suggest you begin with our video on making your very first game in Godot. Alright, without further ado, let's learn GDScript. But first, this video is sponsored by Codecrafters. If you've been writing software for a while and are looking to take your skills to a whole new level,
okay, I did not mean to do that. I gotta be honest.
Codecrafters allows you to practice writing complex software by challenging yourself with real-world projects.
Seconds.
It was a test stream!
This is my team.
I
We get
missed
everything
the
done with
first
Monday.com. Sarah
And then
is
the
a senior project
second one
manager, but she has
ruined my
never
streak forever.
We are in an empty Godot project. It's really spacious in here.
I was at
It
a
is
15
custom. Let's begin
streak.
by making a script
You had a
and adding some
15?
code to print a message.
Yes!
we
It
need
was
a
gonna be
test screen,
16,
so
and
let's go
then
and hit
17,
the plus.
and
I'll add in a
18,
node,
and then
rename it to
69.
main, and let's save this as a scene. So
I'll
hit
reach
Control S,
69
hit
first.
save. Let's add a script by pressing the scroll.
I
We'll
have-
use the
Loser.
default template,
Freak, I
and
swear
the name
to
of the
God.
script
I have
should
a-
remain as
I have a
with
40
1
streak.
You don't.
This creates a script with
I
two
was about to
functions.
say,
We'll start by focusing on the
you
top one
can't take
named
my
Ready.
favorite,
Think
one
of
of my
this as
favorite
the
numbers
start
from me.
of our
That's not
game.
fair.
As it says here, this function is called when the node enters the scene tree for the first time, which happens
Cause
right
I'm a
when we play our game.
cracker, yes
So we can
I
put
am.
code in here that we want to happen immediately. I'll get rid of the other
And the
functions
video
for now.
wasn't even
You can
long
zoom in
enough
by
to
holding
save
down
my
control while scrolling. Now right now the only thing in our ready
What's wrong
function
with
is the
you?
pass keyword.
Get on
It
there.
simply means do nothing. And it will
Oh
appear in
frick, why is my thing not working? Godot mentioned true. Guys. This might be a YouTube video, I don't know.
Maybe.
Yeah, this is all me.
haven't filled out yet. So let's replace it with some code that prints our message. We'll write
Why did you time out Cool Kid again?
You're going to stay timed out for the rest of the thing for taking away the Hulu for the rest of us.
Do not do that.
print, and inside of the parentheses we'll put
I know how to do this. Screw that.
press the might have made with a new line. There's no need to add a semicolon at the
Fails
end.
immediately.
This is indentation to determine the structure of your code. This means that you use tabs to tell you that
You never speedrun coding.
P
I tell you that much.
do those. But I can teach you how to script. Modifying nodes 1.0. First
Wait, brackets mentioned? What? Hold up, let me open Godot. Because I can. Oh god. Alright. We're doing the Trivial Skyscraper. And we have Brackies. The guy who made the video. Don't worry, guys, I'm going to like the video and subscribe. Anyways,
need a node to modify. Let's use a label. So I'll add a new node, choose label. I'll zoom in, center it on the screen. Make some more room. Let's add a default text. This is a label.
this is a just this is a label. I'm sorry. Alright, I'm gonna transition this to Godot. And this is obviously a 3D game. This might be a label. I don't know. What's a labile? I'm sorry, but just the labile. Anyways.
I'll center it and override the font size. Now to edit the I'll center it and override the font size.
Alright, theme overrides. I'm gonna go into theme up your butt. Wait, no. I'm gonna go ahead and go back to now. Guys, this might be a label. Hold up. Hold up. It would be so funny if just the title screen of it is just... the triples. Hold up, hold up. It's just so fun. Alright. Alright, I'm gonna go ahead and keep this. This one is going to be for this. Oh god. Alright, put this right here. Alright, we're gonna delete the window capture. Alright, now we can see the speedrun timer. Why do I have so many browser sources? I'm sorry, but what? Oh god. It's kind of laggy.
Oh, now this guy's going that way. Now I'm getting the lay of the land.
It's just live split. The Trivial Skyscraper. The Trivial Skyscraper. This is a label. Horizontal line center. Okay, I'm gonna head to...
Now, to edit the text of this label through script, we need two things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text. If we hover over text, we can see the name of the property through script, which is text with a non-capital T. So in our main script, we'll first get a reference, and we can actually do this by simply taking the label and dragging it into our ready function.
Alright, let's just make a script for this. Okay. Why is it just freaking? $472 or something. Now let's run this. Alright, let's start this. Heck. How do I do it? Hold up. The string. The string. Oh my god, it works! Hold up, what if I make a variable? Or something, and then set it to the variable. Hold up, this should theoretically work. It works! It works! I'm good. I'm actually good at coding. What the heck?
Then we can access the property by going dot, and we'll type in text and set it equal to hello world. And now when
My least favorite thing about Godot, forcing me to cast everything to string. Eh. It's not too bad, unless you have a lot of integers that you would need inside of a label.
we play as well, such as the and let's check it. And voila, right now notifications.
So you want to be a software engineer? Go to boot.dev, make a free account, write some code, run the code.
Write some code. Run the code.
Input. Let's say we want to turn this label red when we press project settings, input map. Here
I know I can do
my action. Just like ready, this is one of the built-in functions of Godot. But instead of being called at these, just like in our script, we need to create an input function. We'll write func for. Now, just like ready, this is one of the built-in functions of Godot. But instead of being called at the start of the game, it runs every time the game receives any input, such as when we press a button. Event is what we call the information about what event up here, my action. Then we'll put in a colon And if we pressed my action, well, then we'll change the color. So we'll drag in the label, write .modulate, and set it equal to color.red. And we can just as easily check if the action was released. We'll go if event.isAction released this time, my action. Well, then we'll take the exact same line and change it back to green. So now back to green. That's right. Press the space bar, it turns red, and when I release it, it turns back to green. That's right, we made a party. A disco party.
Yes! Yeah! Disco party! Let's go!
We made a party. A disco party. Now this is just one out of many ways to handle input in Godot, but since we're focusing on the GDScript language, I'm not going to go further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable, the name of our variable, and
Okay, so basically like freaking JavaScript.
then we'll
Got
set it
it.
equal to a default value. Now we can print this variable inside of our ready function. We'll write print health. And if we play, you can see that it now prints 100. Now we can easily change our variable. So before printing, let's assign a new number. Health equals 40. We can also assign a calculation. So health equals 20 plus 30. We'll set our health to 50. We can also add health plus equals, and then 20 will add 20 to our health. And subtract health minus equals. To multiply, we do times equals, and to divide, we do slash equals. So if
And
we
then
run
slash
this now, it will
slash,
do
I
all
think.
of these calculations from top
I think double forward slash freaking only returns the remainder, I
to
think.
bottom and then print out the result,
Of
which turns
when
out to
dividing.
be 120. Let's look at an example where our player takes some damage and we want to subtract the damage from our health. Let's try decreasing our health variable whenever we press the action we made earlier. So in the input function, we'll check if the action was pressed, and then we'll subtract from our health. And we can print the result.
No!
So now every time I press the space bar bound to my
He's
action,
he's
we can see that
dying! No, he's dead! He's dead, no!
I reduce the health. Really cool. But as you can see, we can currently reduce our health below 0, and nothing happens when we do so. If we were making a game, we'd probably want our player to die and the game to restart. Luckily, we can make our game react to variables by using if statements. If statements, or conditionals. If statements are the glue that holds all of our logic together. We've actually already used if statements to check if our action was pressed, but they can do so much more. Yet they are really simple. An if statement is just a condition that needs to be met in order for the code inside to be run. Let's add an if statement here to check if our health reaches 0. So I'll make some room, write if health is less than or equal to 0. Well, then we'll set our health to 0, and we'll print that we died.
No! He's
He's 0
dead!
prints you died. Now here we're using less than and equal to compare our health to the value 0. But there are many more comparisons we can make. Here are all the comparisons we use, such as is equal to, is not equal to, and so on. We can also add more conditions to one if statement. We use the AND keyword to add another condition where both need to be met, and the OR keyword to add a condition where only one of them needs to be met. Now, one really useful thing about if statements is that we can not only define what happens when the condition is true, we can also choose what happens when it's false. We do this using the else keyword. Let's add an else to print that we are still alive if our health hasn't reached 0 yet. So if our health is less than or equal to 0, we died. Else, we print you are healthy. And even cooler, we can chain together if statements
healthy.
using else if or elif for short. So we check
You
if
are
our
healthy.
health reaches 0, and
You're
if
so-
not, else if elif our health goes below 50, well then we'll print that we are injured. And if neither of these two are true, we'll go to else and say that we are healthy. And if we play, we can see that at 80 we are healthy, at 60 we are still healthy, then we are injured, and at 0 we die.
No!
Note that the if statement we made here is nested under another if statement. You can easily layer if statements to get more and more specific functionality. However, try not to overdo it. You can quickly get lost in the ifs. Actually, a lot of people don't know this, but that's why programmers and philosophers have so much in common. We both tend to spend a lot of time with the ifs and the what ifs. So if you get frustrated along the way, remember that so was Plato. Anyway, that's it for if statements. Comments. We use comments to help explain and remember the what and the why of our code. Adding a comment is simple and can be done above or after a line. So if we have some code, we can make a comment above the line, and this is a comment about the code that follows, or we could make one right after. And this is a comment about this line only. We can also use comments to temporarily remove parts of our code from being executed. Here we simply put a hashtag in front of the code. And it's good practice to omit the space here to indicate that what follows is code. We can also select multiple lines of code, right-click and toggle comment. Just remember that you can't have a completely empty function. We need to add the pass keyword to avoid an error.
You, just you, building your app on base 44.
Variables 2.0. When creating or declaring a variable, we need to think about where we do so. If we declare a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope, and is something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions. So this is a script-wide variable. This can be accessed anywhere in your script. If you were to declare it inside of a function, you would only be able to use it in that function. So this is a variable we can only use in ready. Now, a really cool thing about variables in GDScript is that you can declare them without thinking about what type of data is inside them. Here's a variable that is either true or false, and here's a variable that stores a number. As you can see, they're created in the exact same way. In fact, we can even change the type of data that they hold just by reassigning them. So we can actually set our coolness to true, and this runs completely fine. That being said, we still need to be aware of what type of data we are working with, because some parts of our game will expect a specific type of data, and we will get an error if we try to use another type without converting. Now, in GDScript, we have the 4 classic data types: Boolean, or bool for true and false, integer, or int for whole numbers, float for numbers with decimals, and string for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if we have a number that is equal to 42, and we have some text, which is a string, well, then we can add the number to this text, and we convert it into a string.
Now I can finally do my code. Heck.
By writing str for string, and then
Oh, I hate this already. Yes!
the variable inside of the parentheses. And if we print this, it works fine. We can do a similar thing to say convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by going int pi, and let's print this. And it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3.
That's just...
Some other data structures that are really common
truncating
in
is just advanced flooring, is what I would say.
2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions, so I can create a variable called position with some coordinates. I can then modify one of the components, so position.x, plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5.
Alright, gotta go into that position in Minecraft 1 sec.
Now, by default, GDScript is what we call dynamically typed. This means that we don't define what type of data a variable can hold when we declare it, which we've been using so far. This makes it fast to create variables and flexible because we can reassign data of another type at will. However, it is also more prone to error and less performant than static typing. Luckily, GDScript allows us to statically type any variables we want. We can pick and choose totally based on preference. To statically type a variable, we simply add the type when declaring it. So here, if we have a damage variable, we can specify the type and then set the value. So now this variable will always stay an integer. We can even have Godot automatically determine the data type by simply writing := and then the default value. This is called inferred typing, and the result is exactly the same. The type is still static. Godot simply recognizes that 15 is a whole number and sets the variable to a type of int. This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game. And we can always press the circular arrow to revert back to the default. Now, sometimes you want to define a variable that cannot change. For this, we use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters. And we'll set it equal to -9.81. Now we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables.
I wanted the word cuppa, as in cup of tea, I thought it would be great to mix with hug. When I
Great job! Functions. Functions are the bread and butter of programming. They allow you to bundle up your code in small reusable packages. So far, we've been using some of Godot's built-in functions like ready and input. Notice how these are prefixed with an underscore. This is to show that they are not activated or called by us, but by the engine itself. But we can actually make our own functions and use them to do really cool things. Common functions to making games are things like jump, die, shoot, and respawn. And making a function is actually really easy. Let's make a function for jumping. So we'll write func. Then the name of our function, open and close parentheses,
Okay.
and a colon. Then in
Okay, this is honestly really funny.
here we'll put all of our code for jumping. So we could add an upwards force, play a funny sound, and a jump animation.
Play a boy.
For now we'll just print jump. But nothing is currently triggering or calling our function. Let's call it whenever we press the action we made earlier. So func_input event, and if our action was pressed, then we call our jump function by writing jump followed by open and close parentheses. And now when I press space, it displays jump. And at this point, I encourage you to add the sound effect yourself. Boing,
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 boing. A
boing.
lot of fun to be had here. Now this already makes our code
it just keeps going.
or readable and reusable. But right now, our function is just a simple command. We call it and it does some things. However, we can actually use functions for much more than this. They can have inputs and outputs. Let me explain. I like to think of functions as machines. Take for example this coffee maker. Just like the name implies, it performs a function to make coffee. To do this, however, it needs some input, some water, a filter, and some ground coffee. With this, it performs its function and then spills out an output, delicious coffee. In code, we call the input we give our function parameters, and the output is called returns. So let's make a function that adds together two.
So what I'm getting here is you can add your parameters inside of these brackets, and then at the end, you just return it.
Two numbers, func, add, and then inside of our parentheses, we add the parameters. So number 1 we'll call num1, and the second number we'll call num2, Then inside our function, we can add these together and store them in a result variable. So we'll set that equal to num1 plus num2. And for now, let's just print the result. Then in ready, let's try calling this function. So we'll call add. We'll give it the first number, 3, and the second one, let's do 8. And let's actually call it again. So let's do a harder one. Let's add 245 with 111. And
That's
indeed, it brings
356.
3 plus 8, which is 11, and 356, which is the result of our second calculation. So here we've created a function with 2 parameters, the numbers we want to add together. But the function actually doesn't return the result. It just prints it. This means that we can't actually access the result where we are calling the function up here in ready. To return the result, we replace print with return. So we'll do return result. And now up here, we can store the result in a variable, set it equal to add, and we'll add together 3 and 5. And we can print that. And the result is 8. And because we have access to it up here, we can do more things, like add more numbers to it. So we can set result equal to add, and pass in the result from before, and add 10, and then print it. And there you go, we now get 18, because 3 plus 5 plus 10 is 18. Really cool. And just like when declaring variables, we can also statically type parameters and return types to make it clear that the function is made to work with numbers. So after num1, we'll specify that this is an integer. We'll do the same thing with num2. And here we can set the return type using an arrow, and this is also an integer. So now this function will only work with numbers. 3, 4, 6, 8, 2, 1, 1.5. Random numbers. Getting random numbers is very easy. The function randf gives a random number between 0 and 1. It's great for assigning probabilities to your code. Say we are deciding what loot to give the player and we want to make some loot more rare than other. Well, in this case, we could create a roll variable and set it equal to randf. Then we could check if the roll is less than or equal to 0.8, which means there's an 80% chance that we print you found a common item. And if not, well, then there's a 20% chance that we found a rare item. And if we play this, most of the time it's going to display that we found a common item. But if we keep playing, eventually there's a 20% chance, so at some point we'll eventually find a rare item.
It took 18 attempts.
That was crazy. We can also use randf_range and randI_range to get a random float or integer between a minimum and maximum value. Say to assign a random height to a character. So var character height equals randI_range for a random integer between 140 and let's do 210. And we'll print that your character is, then we'll insert the height, remember to convert to a string, centimeters tall. And we'll roll a character, and apparently I am a giant. Basketball, here I come. Documentation. GDScript is actually pretty well documented. And one of the really cool things about it is that the documentation is linked with the editor. If we hold down Control and click on something we would like to know more about, such as the randI_range function, it opens up the documentation right here in the editor. This is a really quick and easy way to check if you're using a function correctly. It also works for classes, which we'll learn about later. Arrays. Sometimes you want a variable that can hold more than one thing. In fact, sometimes you might want to store a whole list of elements. For this, we use arrays. Defining an array is very easy. Let's make one to hold items in an inventory. So we'll create a normal variable and set it equal to open and close square brackets. This creates an empty array. We can then add elements inside the square brackets. I'll add a potion string, the number 3, and the number 6. Notice how, unlike many other languages, GDScript has no problem mixing data types within an array. But if you want to constrain an array to a specific type, we can of course statically type it. So here we simply add the type. This is an array, and the elements inside it are going to be strings. So that's the syntax for that. And now we get an error because 3 is not a string, so we'll replace this with feather. And 6 is also not a string. We'll replace that with stolen heart. Now the way that we access elements in an array is by using an index. When you add an element to an array, it is automatically assigned a number based on its position in the array. In this case, the first element, potion, has an index of 0, feather has an index of 1, and the stolen harp has an index of 2. So to access and print the first element in our array, we write print items, and then we access the first element, which has an index of 0. And this spells out potion. Pretty cool. We can just as easily change elements. This changes the second element to smelly sock and the third element to staff. And arrays also have functions for finding, removing, or adding new elements. So to remove at an index, we write remove add, and then the index 1. This removes the smelly sock. And to add a new element, we write dot append, and we'll append an overpowered sword to the end of the array. Now, arrays can quickly become long and difficult to manually go over. Luckily, we can use something called loops to help out.
In this video, I'm going to be making a 3D game in just 1 hour, but all the 3D assets in the
Loops, loops, loops. Loops allow us to repeat code a number of times with small variations. They are perfect for iterating through all the elements in an array.
like for loops.
If, for example, we
That's
wanted
what
to
I'm
print
doing.
out all the items in our array here, we can do that easily by using a for loop. So we write for, then the name of the item that we're currently looking at, we'll just name that item. In the array, so in items, we will print out the current item we're looking at. So print item. And as you can see, it prints potion, feather, and stolen harp. This is cool because we can have any number of items in our array. The code will work just fine. We can also add more functionality, say to only print items that are more than 6 letters long. If item.length, so the amount of characters in item is greater than, let's say 6, then we're going to print that item. And now it only prints feather and stolen harp, because potion is exactly 6 letters. We can also create loops that run a certain amount of times. If we write for n in 8, it creates a for loop where the variable n starts at 0, then goes all the way to 7. So if we print n, we can see that it runs 8 times and n starts at 0 and ends at 7. We say that n is the current iteration of the loop. Another type of loop is the while loop. This repeats as long as a certain condition is met. Now, I think most people who know me would say that I'm a glass half full kind of person. And to those who disagree, let me go ahead and prove it by using a while loop to fill up a glass halfway. So I'll create a glass variable and default it to 0.0. The glass is currently empty, no arguing about that. Then we'll create a while loop that continues while glass is less than 0.5, so we haven't filled it up halfway yet, in which case we will add a certain amount to our glass. We could do a constant amount like this, or in real life when I try to pour something into a glass, I'm not that precise, so let's add a random number instead. So we'll add a random float between 0.01 and 0.2, and then we'll print out how much is in the glass at the current time. Then, when the loop is done, we get to continue down here in our code and we'll print that the glass is now half full. And if we run this, we can see that the glass slowly becomes more full with a random amount each time, and then it says that the glass is now half full. As you can also see, it overshoots a bit because we're adding a random amount each time and not clamping the value, just like when trying to hit exactly half a glass in real life. My wife says that I add too much milk when I make her coffee. I think I'll refer her to this going forward. Now, we actually have to be really careful when using while loops, that we don't create an infinite loop. These can be tricky to avoid and can very easily crash our program. Say if I were to remove this line that adds a little bit to our glass every time, well then our glass would actually never become half full and we would be stuck in this loop forever. Now, I don't think this will actually crash Godot, indeed it didn't, but we get a lot of overflow errors, and as you can see, our game is definitely not responding. Not good. Finally, in both for and while loops, we can use the break and continue keywords. Break, as the name suggests, breaks out of the loop and moves on to the code after, while continue immediately skips to the next iteration of the loop. So if we were to write if glass is greater than 0.2 and then break, we can see that our while loop ends way early because we exit out of the loop before we even get to print that the glass reached 0.2. Dictionaries. They sound really boring, but they're really cool. While arrays are great for storing lists of elements, it's sometimes confusing to access each element with an index. Sometimes it makes more sense to use a dictionary. Dictionaries hold what we call key-value pairs. Let me explain. In real life, we use a dictionary to look up the definition of words in a language. The key in this instance is the word we are looking up, and the value is the definition. Dictionaries in GDScript work the exact same way. Creating an empty dictionary is really easy. We write var, I'll call this one my dict, and set it equal to some curly brackets. This is an empty dictionary. We can then add key value pairs inside the curly brackets. Say for example that we have multiple players in our game. We can use a dictionary to keep track of them. Each player has a username, this will be the key, and a level. This will be the value. So I'll create a player called Crook, and his level is going to be 1. I'll create another player, Villain, with a level of 35. And finally, a player with the username Boss with a level of 100. If defining on one line becomes too much, you can split it up like this. And it's good practice to add a comma to the last entry so you're ready for a new one. And let's name this dictionary Players. Then, to get the level of a player, we simply type in the username. Let's print the level of our villain. So print, and we'll write players, type in villain, and this should print 35. And you can just as easily assign a new value or add another entry. So we can reassign the villain here to say 50 and add a new entry called Dwayne with a whopping level of 999.
Good God,
And just
The
like
Rock.
with arrays, we can loop over a dictionary with a for loop. When we do this, we are actually looping over all the keys in our dictionary, so all the usernames. And for each username in players, we will go ahead and print out the username. I'll add a string to separate, and then the level. So here we access our player's dictionary and input the username we're currently looking on to get the value. And remember to convert this into a string, so str, to cast to a string. There you go, it prints our entire dictionary. Now, just like with arrays, you can have multiple data types of keys and values in the same dictionary. And even cooler, you can actually have arrays or dictionaries inside another dictionary. This might sound really abstract, but it's actually pretty cool and often comes in handy. Say for example, we don't just want to store the level of each player, but also other info like their health. Well, then we simply replace this value with another dictionary. So open and close some curly brackets. Here we'll add a key called level with a value of 1, and another key called health with a value of 80. And at this point, it's a good idea to use tabs to keep our code clean. Let's duplicate this. I'll assign some values. And now we can access the value by using two keys. Let's print the health of our boss. So print players. We go into our boss and we access the health. And this prints 500, which is correct.
Good God!
So this way we can start to think of ways we can structure data about what's going on in our game, such as player stats, inventory, buffs, and so on.
It just
Moving on
happens to
stakeholders
be.
shouldn't be your job.
It just
Try
happened to be.
Enums. Enums are a convenient way to define tags or states in our game. Say we're making a game with a bunch of units and we want a way to mark each one as either hostile, neutral, or ally. In this case, we could create an enum that defines these tags. So at the top here, I'll write enum to create a new enum, and then in the curly brackets, I'll write ally, neutral, and enemy. And now we can use these states in our game. For example, we can create a variable called unit alignment and set it equal to any one of these states. I'll just set it to ally. And this makes it really quick and easy to then check in our code if our unit has a certain alignment. Also, let's just give our enum a name here to stay organized. So I'm going to call this alignment. And now whenever we are accessing a state, we have to go inside of alignment dot, and here you can see our state. So I'll go alignment dot ally by default. And then inside of ready, we can check if unit alignment is equal to alignment dot. Let's check for enemy. And if it is, we will print you are not welcome here. And if it's not, so it's not.
So basically, if unit alignment is an enemy, it's just frick off.
An enemy,
Screw
we'll
off.
just write welcome. And now if we run, we can see that our console displays welcome because our unit alignment is currently ally. This is much safer than using, say, a string or an integer to represent states, because Godot will throw an error if we misspell a state. If, for example, I misspell enemy, we can see that Godot throws an error. But I think one of the real powers of enums is that we can use them for exported variables. To do this, we mark our variable here with export, and then set the type to alignment. And now we can actually set our unit alignment in the inspector. So I'm going to set mine to enemy here, and now when we play, it prints "you are not welcome" here. Really cool. Now what is actually happening behind the scenes here is that Godot is creating a constant for each state in our enum. So this code here is actually completely identical to our first line. And as you can see, the value here increases from 0 to 1 to 2, kind of like an index. So an enum is essentially just a bunch of constants with an increasing value. Which means that if we try to print one of these states, say we print alignment dot enemy, the console simply shows the value of that constant, which is 2, because it's the third state. This is rarely something you need to take into account, but it's nice to know what our code is actually doing. And we can even override the default value if we want. So we could set ally equal to 1, neutral equal to 0, and enemy equal to -1. And now our console displays -1 because that's now the value of our enemy constant. Now something that pairs really nicely with enums are match statements, because they allow us to quickly add functionality for each state. Match. Match is the Godot equivalent of the switch statement from other languages, and allows us to execute different code depending on the value of a variable. In this case here, we can use a match statement to add some code for the different values of our enum. So I'll write match, then the variable we are matching based on, which is my alignment, colon, and now we add code for each value. So in case my alignment is alignment.ally, I'll print hello, friend. If it is neutral, I'll print I come in peace. If it is enemy, taste my wrath. And a cool thing here is that we can actually add a default response as well. To do that, we do _:, and so if it isn't any of the cases above, we'll print who art thou? And if we set my alignment to say enemy, taste my wrath. Modifying nodes 2.0. So far, when we need to access a node, we've done so by simply dragging it into our script, which creates a $sign followed by the path to the node. I've created a few empty nodes here to demonstrate. A player node with a graphics and weapon node, and an enemy node. So if I drag in the weapon node, it creates a path that goes into the player and finds the weapon. And we can actually store this reference in a variable. To do this, we simply drag it to the top and hold down Ctrl while releasing. This automatically creates a variable with the name of the node and the correct path. And as you can see, it uses the onReady keyword. This is because Godot has a very strict order in which nodes are created. And if we open the game and try to find the weapon node before it exists, we will get an error. OnReady simply makes sure that Godot waits until all child nodes have been created so we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node. We can print the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now paths are great for many things, but sometimes they can be a bit inflexible. They break if we rename any of the nodes in the path, and it's best to only use paths when the node we want to access is a child of the node we are working on. We'll talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node2D, in which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we only want to reference sprite nodes, we just change the type to sprite. So sprite 2D. I'll reset the variable here, and now we can only assign sprites, which in this case are the graphics and weapon nodes. Now if we play, it still prints that this node is a 2D node, even though sprite 2D and node 2D are two different nodes. This is because sprite
Bro
2D
has a GTX 1080 Ti.
inherits from node 2D, but we'll get into that in the inheritance chapter.
Did you know you can AFK Bloods and Zaya whilst learning to code in Python? Go to boot.
Signals. Signals are messages that nodes can send to each other. We use them to notify that a certain event occurred. It's probably easiest to look at an example. Godot has many built-in signals. Take this UI button. If we select it and go to Node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double-click it, I'm going to select main and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here. And
Money!
If we play and press the button, it prints money.
Money!
Get it? Now this is because whenever we press the button, it emits the pressed signal and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then, all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, I'll create a timer. So I'll add a timer node and set it to auto start. This will count down from 1, and when it reaches 0, it emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0. Then in our function, we increase our XP, and let's also print it. If our XP then reaches, say, 20, we'll set it back to 0, we leveled up, and we can start over for the new level. And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's create a signal that other nodes can connect to. So at the top we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveledUp function, which is called when the signal is emitted. Let's print a message that says ding. Now we simply have to emit the signal. Let's do that when we reach 20 XP. Here we'll write leveledUp.emit. Now when we reach 20 XP, it emits the signal and we print ding. Awesome. We can also connect signals through code. I'll disconnect the signal in the editor, and instead in a ready function,
that code has a minor logic error, by the way.
Write leveledUp.connect and the name of the function we are connecting to, on leveledUp. Careful here, this will probably autocomplete with parentheses. We don't need those, we just want the name of the function. And disconnecting is just as easy. Disconnect. We can also pass parameters through signals. This could be used to pass the level we reached or other useful information. I'll just add a quick message that we can print. So on a signal, we'll add a parameter. We'll make sure that our function supports this as well. And instead of printing ding, we'll print whatever message was input. And then when we emit the signal, we can put in
Why is that so fun?
a message. Let's put in grats. And voila, it displays grats. And that is signals. Get, set, go. Or
Get set!
Set.
Get
Set, set, go.
This is This is the most professionally unprofessional tutorial that I've seen.
Or just get set. Getters and setters allow us to add code for when a variable is changed. This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0 and 100. So this makes sure that our health does never exceed 100 or go below 0. We could also emit a signal here, so we can create a signal. Health changed, and we can actually input the new health as a parameter. And then in our setter, we can go health changed dot emit and put in the new health. Of course, we need to make sure to connect this signal. We can do that through the editor, and let's just print the value. So we'll print the new health. Then in ready, let's try this out by assigning a value to health. Let's try assigning -150. And now if we play, we can see that it prints 0. This is because we put in -150. It clamps this to 0, and then it emits the signal. The signal then calls the onHealth changed function, and we print the new health, which is 0.
This is why I comment my code, because no.
So that's a good example of adding a setter. Getters are more commonly used to convert values. So let's add two variables. We'll have a chance that is equal to 0.2. And then we can have another one, which is our chance in percent. We'll make this of type int, and we will add a getter. Here, whenever we try to get the chance percentage, we'll simply return the chance variable times 100. And now if we try to print this variable, print chance percentage, or change our chance to, let's say, 0.6 and print it again, we can see that our chance percentage is completely based on whatever our chance is currently equal to. And so it starts at 20% and then goes to 60%. And for good measure's sake, we'll add a setter also. So if we set to a new value, we will modify our chance and set it equal to the new value divided by 100. And since our chance is a float, we'll make sure to cast that value. So now instead of changing the chance, we can directly change the change percentage to say 40. There we go. Classes. This is a good one. TDScript is...
Oh god.
It's an object-oriented programming language. This means that we generally try to structure our code
Chat, here we
inside
go.
contained
We're almost at 1 hour.
objects that interact with each other. We primarily do this using classes. For now, try to think of a class as a blueprint. Say, for example, we are making an RPG and we need to populate it with a bunch of characters that the player can interact with. So we create a character class that has some variables and logic that all characters in the game should have. So for variables, we could add things like name, health, and a line of dialogue for when you interact with them. For logic, we could add functions like talk and die. Then we take and create instances. Instances are
he can
specific
die!
versions of
No!
So we could create an instance named Potion Seller that has a health of 50 and a line that says, "You can handle my strongest potions." And a bunch more instances, all of which have the same variables, but different values, and all of which can talk, "I used to be an adventurer like you," and die. So that's the idea.
No!
In Godot, you've
He died! Anyways, 1 hour. Let's go.
actually already encountered a bunch of classes. That's because all the built-in nodes in Godot are classes, which actually makes a lot of sense if you think about it. All the nodes are self-contained objects with a bunch of variables and logic that we can create instances of. If we add a sprite node, we're instancing the sprite class. So when we create a script, we are actually also creating a class. I have to put a disclaimer here that we are technically not creating a class, but for all intents and purposes, it works just like one. So let's forget all about that for now. So let's abandon our main script here for now and instead create a new node. So I'll search for node and let's name this node character. and add a script to it. Now, to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name, character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var. Let's add a profession of type string and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times. The second character here will name X Adventurer with a health of 30. And the last character will be our knight, and we'll give him a health of, say, 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So I'll write func die.
He's gonna die!
This function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a reference, but because we have named our class, we can actually use an export variable for this instead. This way we can set the connection in the editor and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the character to kill. And we can either drag in one of these characters or hit assign and select one. I'm going to choose character 3. And now in our ready method, we simply go to our character to kill and call the die.
No! He's done! He's freaking dead!
Is called on our character 3, which is our knight. So it says
he freaking died! No!
Died. And if we choose another character, say the first one, we are instead killing the potion seller. Really cool.
We have got to the point where literally anybody can build a fully working app without knowing how to code. This is base 44.
Inner classes. These are classes that exist inside of another class. We mostly use these for bundling together variables and maybe add a function or two. They can be a good alternative to dictionaries because they are sometimes a bit more safe to use. Say we have this character class here and we would like to add some equipment. We could create an inner class called equipment. So I'll write class equipment, and then we can give it a couple of variables. I'll create an armor variable, set it to 10 by default, and a weight of 5. Now we can use this class around our script. So we could create some variables using it. I'll create a chest that is equal to equipment.new. Calling .new will create an instance of the equipment class. So now we have one piece of equipment, one instance, which is a chest. We'll also create legs, and again we'll call equipment.new. Then in the ready function, we can access these classes. So we can go into our chest and change the armor and set it equal to 20. We can then print chest.armor, or maybe print legs.weight. And this is also where you can see that this is sometimes safer than using a dictionary, because TDScript will recognize that there is a weight variable inside of the equipment class. And if we try to access something that isn't there, we'll get an error before playing the game, not only when we reach this point in our code. This is called being type safe. And now if we run this, we can see that each of the instances of our character will print these two pieces of equipment. And the armor of the chest is 20, and the weight of the legs is 5. Inheritance. So we know that all nodes in Godot are classes, and we can effectively make our own using scripts. But there's one more important thing we need to know to understand how Godot is structured: inheritance. Inheritance refers to the ability to derive one class from another. We've actually already been doing this. Notice how our script says extends node. So our script derives from the node class. This means that all the functions and variables of the node class are also available in our script. Godot actually has a very nice way of visualizing this. When adding a new node, we can see all the nodes available to us, but some of these are organized under other nodes. That's because these nodes inherit from the top ones. For example, both Animated Sprite 2D and Camera 2D inherit from Node 2D. This is because Node 2D is a base class for all things that exist in 2D space. So since both a camera and a sprite needs a position in our world, they both inherit from it. And even cooler, we can actually find our character class on this list as well. That's because when we create a character class, we're essentially defining a new node type. And we can see that it inherits from node. Really cool. Now, all of this probably sounds a bit abstract, because it is. But what it means in most cases is simply that we need to make sure we inherit from or extend the right class for what we're working with. If, for example, we are making a script that moves around our player, we would create a character body node and add a script to that node. We could name it, say, player. And as you can see, this script then automatically extends character body 2D. And we now have access to all the functionality in it, such as the velocity and the move and slide function, which moves the node around. Composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. Call down, signal up. When writing GDScript, there are of course many best practices that we can choose to adhere to. Going over all of them is a video on its own, but one that is particularly important is call down, signal up, which we use as a rule of thumb when communicating between nodes. Every scene in Godot is a tree of nodes, and the beginning of the tree is called the root node, which is the highest in the hierarchy. When looking at two nodes where one is right above the other, we say that they have a parent-child relationship. The node that is above is the parent, and the node that is below is the child. And that child might also have a child, and so on.
Ah. So it's kind of like Roblox in a way, because it has a dot parent in it. It's like the Lua inside of Roblox.
Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy, but not vice versa. Instead, nodes below should use signals to communicate that something has happened. The nodes above can then connect to these signals as they choose and act accordingly. Think of it like real life. Parents are allowed to tell their children what to do, but children shouldn't directly command their parents to do things. Instead, children signal their needs to the parents and the parents decide the next step. Now keep in mind that this is a way to remember a good coding practice, it is definitely not parenting advice. But what if you need to communicate between two nodes that are on the same level? You guessed it, these are called siblings. Well, here the common parent is in charge of connecting the signal from one sibling to the function on the other. This is most often done in the ready function right at the beginning. So that's the idea of the rule, but of course always implementing this concept correctly requires some practice. I'll have a link to a good article with some nice examples. Style. During this video, I've tried my best to adhere to the official GDScript style guide. These are the conventions we use for naming and order to keep our code elegant and readable for others. I won't go into further detail here, but I'll have a link to the official guide. That was a lot of code for one video.
Alright. We've done the first split. Finally. Hold up, I gotta... Hold up, I got a whiteboard. Alright. I can't believe it, chat. I got a gold split. Alright, now time to use that to, make a game. Alright. Well, we gotta make some artwork, so we gotta get into Piskel. It only took me an hour to learn how to code, instead of like 7. Sunshine Mario is the best Mario. Hold up, I gotta actually 1, 11, 43, 27. Chat, we gotta make some stuff for the game. Thankfully, I've already made like 10, like, off of here. We have a coin, which sort of looks like a ball for some reason. What is... $5 bill. Friggin' ruby, diamond, whatever this is. Piece of coal, maybe. This is not the one that I'm looking for. 78 frames! I'm sorry! Alright, so I go ahead and add a thing to my sack. We're making a sack, chat. I'm I'm trying to make a sack. Look at Not that kind of sack. Now it's time to hat. Now it's time to dither. Right, I think I've made a successful sack. Hold up, I'm just gonna go. JC, do you like my sack? Watch him go, oh, so that's what he meant by sack. That's a big nutsack you got. Shut up, it's not a nutsack. Alright. Now it's time to put a money symbol. Can we ban JC? Wait. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we go up. It's not a nutsack, JC.
Nice nutsack you got there.
It's not a nutsack. Fuck! Wait.
Deshiel is making his sack skies.
I mean, yeah, I am making a sack, but not the sack that you think I'm making. We have made a $sign, chat. We have made a successful money symbol. It's money shot. Oh, how does this look in post? Not too bad, I'd say. And I think it needs some shading. Now we gotta pick this. Oh, frick, I swapped. Alright, how does this look in post? Not bad, I'd say. Fudge. Delete this layer. We're gonna paste it. Oh my god, that looks better than I thought. Like, I'm not even joking. Hold up. Hold up, I'm gonna go ahead and go into the arch. Guys, I need feedback on my sack. Right? Okay. Someone clip that. Someone freaking clip that. I would like feedback on my sack. Rate it out of 10. It's just the freaking I love the out of context. Nutsack. All right, here, etc. We have made a semi-good vein right here. Dun, 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 dun. Eh, 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 eh. Eh, 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 eh. Em, 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 em. Em, 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 em. Em, 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 em. Em, Man, hold up. I need the Me Shop theme. Me Shop. Me Shop theme 10.
Zaxby's just dropped a whole new line of dry rubs, and they're not playing around. Who's got the sauce?
With Purdue Global, education fits your life.
Oh, good God.
So being a mom and a
Aloysius Minch can go to hell just like all the other scrawny bastards.
I need a shield. How am I supposed to do that with what? We'll outline it.
Aloysius Minch can go to hell just like all the other scrawny bastards. Aloysius Minch can go to hell just like all the other scrawny bastards. Aloysius Minch can go to hell just like all the others.
No. Look, what if I just make a circle? Just make that the shield. Alright, we're gonna go 1, 2, 3, 4, 5, 6. Hold up, pause the timer real quick. We need a Osu chart of the frickin' Wii Shop music. Wii Shop. It's right! It's frickin' right!
Do you even know who Aloysius Minch is?
No. Na 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 na. I did not do that. We need the Wii Sports theme because why not? Wii Sports is peak.
Welcome to us.
Click the circles.
Because I want to see the Wii Sports chart. Circles. Click.
Aloysius Minch.
Screw you. I kind of want to see this too. Look up Oasis Minch, please. No! Screw you. Alright. Well, that was something. I'm not looking up Oasis Minch.
Look up Aloysius Minch, please.
Wait.
What?
DT. DTHD.
Who's Omar? Oh, Susu?
I went up 37.
See you next time.
Look up Aloysius Minch, please, or else I will earthbound your sacks to a thermonuclear bomb.
Actually, a thermonuclear bomb inside of my game isn't such a bad idea. Oh frick, that's the wrong one. Actually, you know what? I'll actually add a thermonuclear bomb to my game. Anyways, we're starting the timer again. And we have... Pull up.
Look up Aloysius Minch, please, or else I will earthbound your sacks to a thermonuclear bomb and blow up Texas and Rhode Islands.
You're welcome. This is it. This is the bomb. Now, if you want me to add WD Gaster, that's one gifted... No, I'm just kidding.
Now make him an enemy you can murder in cold blood.
No. We're gonna make a stroke. That's right, chat. I'm stroking it. Wait. We're not taking that out of context, right? Why is that? Why does that actually look good though? All right, now boink. All right, we're gonna. Do this. We'll do that. And do this. And this. Go heck.
Did anyone else see that? Must have been the one.
Hey, yo, what? All right, now time to. We're gonna add. I don't know. I don't know what to add on this. Bim, 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 bim. Hold up. It would be really funny if I just. Guys, I made a bomb out of bip, 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 bip. Rap, bip, rap, bip, rap, bip, rap, bip. Rap, bip, 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 bip. Bip, 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 bip. Bip, bip. Hold up, it would be funny for one of the songs to be just a rendition of the frickin' Wii Shop music. But I think I'm gonna call it here, chat. I'm calling it here for tonight. Thanks for watching. Nice and chill 2-hour stream, I'd say. And I gotta get to bed.